So you learned the definition of velocity and definition of speed. So in linear motion, by linear motion I mean the motion that takes place in one direction. So it could be horizontal, it could be vertical, it could be a motion in a plane, but it has to be in the same direction. Right? So velocity is a vector, unlike speed, which means you have to take direction into account, right? So if you are considering only one dimension or one direction, speed and velocities are merely equal, right? So we can say speed is equal to the magnitude of velocity, right? So velocity, the definition is displacement divided by time. Displacement divided by time. So when we define velocity in that way, so we don't know what happens. We don't say the velocity of a particle at a certain instant. We can't say. We always have to take two positions into account, right? Starting position, ending position, and if you know the displacement between them and the time it takes for the particle to go from A to B, then we can define the velocity. Right? You can see the 2 points has to be there over the time. But we can't say the velocity of a particle at that instance. But when you drive a car, your speedometer tells you the speed of the car at that instant, right? At that instant. So that is called the instantaneous speed. Similarly, we can define instantaneous velocity using derivatives, right? Using derivatives. So you know the definition of derivatives. I'm not going to get into that. This is the applied part of derivatives. So we discussed this under application of derivatives. What is instantaneous velocity? So instantaneous velocity is defined as the change in velocity divided by change in time as the limit of delta t tends to 0. So when the time reaches 0, when the time approaches 0, the difference in time approaches 0, the displacement value. So that is defined as ds by dt. So this is the definition of, this definition comes from derivatives. This is called the differential coefficient, right? So ds by dt. So what is s? S is the displacement, t is the time. So here I mentioned delta s is change in displacement within delta t change of time, right? So we can use this notation. Now this is the instantaneous velocity. So this velocity tells you the velocity of the particle at that instance. If you take a snapshot of a moving particle, then obviously when you take a snapshot, you see a point, right, in space, not moving. But I mean, if there's a way to measure the velocity at that instance, so that is called the instantaneous velocity of a particle, right? Simply put, speed of a car at that moment. So what is the notation? How do you define velocity, instantaneous velocity? So you can say V sub A. So when you say V sub A, that tells you velocity of a particle at position A. Hence instantaneous velocity. So we can read it as instantaneous velocity at A, or simply put, we don't have to mention instantaneous all the time. When we say velocity at A, at refers to a specific position or specific time. So velocity at A is actually the instantaneous velocity. Okay, right. So now we'll talk about acceleration. So you know about acceleration. You have an accelerator in a car. So when you push on the accelerator pedal, the speed of the car increases. So acceleration tells you the rate at which the velocity changes, right? So how speed changes with time, that has something to do with acceleration. If you accelerate, your speed or velocity will change, right? So acceleration is change of velocity divided by time. So how do you find the change of velocity? The change is defined as final velocity minus inertia. So when we talk about change, we always use this final minus initial, right? Not initial minus final, it's always final minus initial. That gives you the change time. So you can say change in velocity, we can say delta V divided by delta t, right? So usually we use a for acceleration. So when we take physics, use a for acceleration. Sometimes in mathematics, usually we use f for acceleration, not a. So but we use a and f interchangeably. So it's the same thing, right? A for acceleration, delta v over delta t. Similarly, we can define instantaneous acceleration, but we don't use instantaneous acceleration much, right? So, but the definition is given because this will be useful for you. Limit of delta v over now delta v over delta t. This is acceleration. So when you define this acceleration, you always take 2 points, right? Point A, point B. Starting velocity, that or initial velocity, and the final velocity, right? So there will be an acceleration, which means if we have initial velocity is different from final velocity, which means there has been a change of velocity. Change of velocity means definitely there has been an acceleration or deceleration, right? If your velocity increases, that means acceleration. If the velocity decreases, that means deceleration. So you know this definition from physics. I'm not going to get into details here. Right. So this takes 2 points into account all the time. Instantaneous acceleration is the acceleration at that instant. So that is defined as delta v over delta t, and we take the limit of this as delta t tends to 0. Right. So that is called dv by dt. This is from the definition. Right. If you know about derivative, this is the definition. Right. So this is dv by dt. So since v is ds by dt, we substitute ds by dt here, so we get d squared s by dt squared. Second derivative of displacement with respect to time, right? Okay, so this is about instantaneous acceleration. Right, so let's look at some definitions. Uniform acceleration. Basically, we are looking at uniform acceleration. As I said earlier, instantaneous acceleration is not used. Uniform acceleration means when the acceleration is constant, it doesn't change, right? Throughout the journey, throughout the motion, if the acceleration does not change, right, that is called uniform acceleration. So sometimes we get problems where the acceleration from A to B is one acceleration, let's say F, then from B to C, the acceleration is 2F, right? So in that case, from A to B, the acceleration is constant, that F, right? From B to C, acceleration is constant, that is 2F, right? So you can say that when the acceleration changes, then you have to consider the motion piece by piece, where the uniform acceleration occurs, right? So within a certain piece, acceleration must be uniform. Otherwise, you can't use the kinetic equations that I'm gonna derive soon, right? So uniform acceleration is defined as acceleration is constant throughout the motion. Then that acceleration is called uniform acceleration. Similarly, uniform velocity, when the velocity does not change, right? When the velocity is constant throughout the journey, that is called uniform velocity. So we don't get uniform velocity problems much, right? It's very easy. So you will get uniform velocity problems in physics, right? Okay, so what does it mean? Velocity does not change mean acceleration is 0. So A must be 0. That point. Right. Then I was talking about motion and all. What is motion? Motion is when a point, what is a point? So I have discussed what a point is under forces, right? So point is a physical quantity that has no dimensions but has a mass, right? It has a mass but it has no physical dimension. So it's an imaginary entity. It doesn't exist in this universe. But for mathematical problems, we use that definition. So when a point is changing its position, right? So now I'm here. Now I can change, right? So within a certain times, I was here, maybe 1 second ago. Now I'm here. Okay. So I change the position, which means I am in motion. So when the point is changing its position, it is said to be in motion. Okay. Then path. What is a path? Path is the curve drawn through all that position, right? The curve drawn through all the successive position. Successive means එක successive positions of the point. Right? What does it mean? Suppose you are at T. Now, this is a plane. Your particle is here. Mass එක ඉන්න මෙතන. Right? Then after certain times, it comes here, 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 here. It goes like this. So if I draw a curve through all these successive points, right? Suppose your ant කෙනෙක් ගමු කූඹියෙක් නම් මෙහෙම යන්නේ නැහැ නේ. ඌ හිමීට වම කූඹියගේ path එක උන්ට තියෙනවා. A path of ants. This is the curve drawn through all the points. That is called the path. This is the path. Right? So here we are only looking at linear motions. So our path is a straight line in that case, right? So we don't get curves. But when we look at circular motion, our path will be a circle, right? So we have to make that distinction. Now let's get into problem solving. So how can we solve problems that involves linear motion? That means particles move in one direction. Right. So like I say, if a particle is moving in one direction, one dimension, horizontal, vertical, or in plane, then velocity change of velocity or the acceleration means actually the change in magnitude of the velocity. Right. Velocity එකක් change වෙන්න නම් direction එකක් change වෙන්නත් පුළුවන්, magnitude එක change වෙන්නත් පුළුවන්. When you consider circular motion, you can see even the magnitude of the speed or the speed is consistent throughout the circular motion. The direction of the velocity changes, right? So there will be an acceleration. Okay, the direction of velocity changes. Now, if you consider linear motion, the direction will not change. I mean, the dimension does not change, right? එතකොට මෙහෙම හැරෙන්නේ නැහැ. මෙහෙම ගිහිලා ආයෙ එන්න පුළුවන්. Right, ගිහිල්ලා එන්න පුළුවන්. Then the direction is opposite to it. එතකොට අපිට දැන් කලින් වීඩියෝ කතා කරා වගේ real numbers වලින් මේක කතා කරන්න පුළුවන්. Right. එතකොට අපි එක direction එකක් positive කියලා ගත්තොත් ඒ direction එකට තියෙන ඔක්කොම vectors positive කියලා ගන්න ඕනේ. අනිත් පැත්තට තියෙන ඒවා negative කියලා ගන්න. Right. Please keep that in mind when we solve problems. So when we solve problems, two methods exist. They are using kinematic equations. So there are 4 types of equations. We'll derive them soon. So we can use the equations to solve problems. So sometimes it's easier to use equation and sometimes it's easier to use graphical method. So second method is using graphical methods. So ST means displacement time graphs. VT means velocity time graph. AT means acceleration time graph. So we will focus on VT mostly, not ST and AT. So we can use, so sometimes using SVT diagrams is much easier to tackle certain problems, especially when two objects are moving, okay, towards each other or in the same direction. It comes in handy. So we'll get to this later. So the first series of these videos will focus on kinematic equation, how to derive them and how to use kinematic equations in problem solving. Okay. Now let's begin with formation of kinematic equation. Now kinematic equations are formed under the assumption that the acceleration is uniform throughout the journey, right? So if acceleration changes, then we have to consider the path piece by piece, where in a piece, within a certain piece of path, the acceleration is uniform, right? So please keep in mind, very important, these equations can only be used for uniformly accelerated motion, right? So you can't use them when the acceleration changes. If the acceleration changes, then you have to break your path into pieces where acceleration is constant, where within a certain piece acceleration are consistent. Then you consider that part and use this equation. So let's see how to build up these equations. Right. So I'm going to use a diagram to assist me with the formation of kinematic equations. So it'll be easier for you. The intuition can be built up on this. Suppose you have 2 points in space, A and B, and you have a particle. It's the same particle, right? Same particle. When it is at A, it has a velocity u. When it is at B, it has a velocity v. So now velocity u means the particle is in this direction. It is moving in this direction. It is in motion in this direction. You can see that when the particle is at B, it's still moving in the same direction. Right? Okay, so this motion takes place from A to B, therefore, not B to A. Now notice here that A, we use double arrow with the acceleration so that I can make the distinction between acceleration and velocities. Right? And the displacement from A to B is S. Right? So you can see the dimensions, how I mark the dimensions using this line and arrow. This is how you mark dimensions. Then time, right? Time. So starting point, time is set t equals 0. Right? When it is at B, let's say time is t. T equals t means time is t. Right? So we're going to consider this motion. Okay. So here are the notations. V is the final velocity, u is the initial velocity, t for time, s displacement, a uniform acceleration. So let's start with the definition. Acceleration A. Acceleration A is defined as change of velocities final minus initial divided by time. T equals 0 t. So time difference is actually t minus 0. So keep this in mind, it's very easier for us to solve problem if you measure displacement from the position at t equals 0. If you measure the displacement from t equals 0, the point where the time is 0, then it will be easier for us to solve problem. Right. So this is t minus 0 is v minus u over t, then cross multiply, then a t equal v minus u, right? Then v equals u plus a t. Okay. So we get the first equation. First equation is v equal u plus a t. This is our first equation. Notice here that we have final velocity, initial velocity, acceleration, time, but we don't have s here. No s. No displacement in this equation. Right. So this is the first equation. To build the next equation, we're going to use the average velocity. Right. So average velocity. Average velocity, now here in this motion from A to B, you have an acceleration. Right. Average velocity tells you the velocity at which you have to move. You should move this displacement, right? You should move so that within a time t you would move the same displacement. ඒ කියන්නේ A වල B වලට දැන් acceleration එක නැතුව ඔයා move වෙන්න ඕන නම් t time එක ගියම 10 seconds වලින් ඔයා මේ displacement එක මේ යන්න ඕනේ කියලා without any acceleration. So that is the velocity that you have to go with, right? So this is called average velocity. Total displacement divided by total time. Okay. So average velocity is v plus u divided by 2. V plus u divided by 2, that is average, equal total displacement is s divided by time. Then we get the second equation, s equal u plus v by 2 times t. Right. So notice here that in this equation you don't have acceleration. Right. So next we're going to build up two more equations based on this equation and the previous equation. Right. So this is the second equation we obtained, s equal u plus v by 2t. So we can replace v from the first equation. So u plus, instead of v, we write u plus at. Then u plus u is 2u plus at divided by 2 when we separate out by multiplying it t. So this would be 2u t divided by 2, which is ut. Then at times t divided by 2 is half at square. So this is the third equation, s equal ut plus half at square. Notice here that v is not there. V is it's not in this equation. So let's look into the fourth type. Right. So what I did here is I started with the second equation, then I replaced t, right? Time. I'm going to replace time. So from the first equation, when I subject t, I get v minus u divided by a, right? Then I can 2 into a into s, cross multiply 2as. Here you can see v minus u, v plus u. That tells you that this is actually the difference of two squares, a plus b into a minus b. So we can write as v squared minus u squared. So finally, if we subject v squared, then we get v squared equal u squared plus 2as, right? So this is the last equation that you will be using. And notice here that you have no t, right? You are not no t. Yeah, you are nice, but we don't have t in this equation, right? So these are the 4 equations. Now let's analyze these 4 equations. Right, so these are the 4 equations I have listed out. Right, so notice here v equals u plus 80. Right, how many unknowns are there? 1, 2, 3, 4. You have 4 unknowns, right? So this is a simple equation. Now problems could be simple and advanced. So when it comes to simple problems, you will have to you will be given 3 data. You will be given 3 data and you have to find the remaining variable. Suppose u, a, t are given, then you can use this equation to find v. If v, u, a is given, you can find t, right? If v, a, t is given, you can find u. If v, u and t is given, you can find a, right? This is how simple problems evolve, right? Second equation, you don't have acceleration, no acceleration. If you know s, u, v and t. So if you know 3 of these data, then you can find the remaining data. Here s equal ut plus half at squared. If you know initial velocity, displacement, time and acceleration, then if you know just 3 of them, you can find the remaining one using this equation, right? So the last one is v squared equal u squared plus 2as. Final velocity, initial velocity, acceleration and displacement. You don't have time here, right? So if you want to find displacement given initial velocity, final velocity and acceleration, you go for this equation. So simple problems, when it comes to simple problems, you know that 3 unknowns will be given and you have to find the remaining unknown. So based on the given unknowns, you have to choose the correct formula, right? Suppose you are given v, u and a and you need to find t, then which equation should be used? This one. v, u and a is given and you need to find t. v, u, a, right? So in this equation you have v and u but no a. Displacement, then if you use this equation, for that you need to know displacement and time. 2 variables are unknowns. So you can't use just a simple equation, just one equation to solve 2 variables. If you want to know solve for 2 variables, you need 2 equations. Okay. So it's very important that you choose the correct equation. Right? So if you are given displacement, initial velocity and final velocity, then you are asked to find time. Then which equation you should use? This equation. Right? If you are given initial velocity, final velocity and acceleration, then you are asked to find the displacement. This is the equation you should go for. Initial, final, acceleration is given, then you can find S. So this is how simple problems evolve. So we'll look into some simple problems. I'm not gonna go into much details with that because we have definitely done it on for physics. Right. So notice here, one important thing. If you observe all these equations, one term or one variable exists in all 4 of them. Can you spot that? U is always there, right? Which means if u is not given, in the problem, then you will definitely have to find the initial velocity, right? So if you are going to use these 4 equations, initial velocity must be there. So even when you draw a diagram, even when initial velocity is not given, it is important that you put the initial velocity in the diagram all the time, right? So otherwise you can't use these two equations, right? These four equations. I mean, we can take two equations and get rid of u, but then we get into more equations, but four equations are enough. Okay. Right. So few things to be noted here before we begin solving problems. So this is the theory part. That's it. Right. Only use the equations when the acceleration is uniform. As I mentioned here, we build these equations based on the fact that the acceleration is uniform, right? So only use the equation when the acceleration is uniform. If the acceleration is not uniform, which means if acceleration of the particle is f from A to B, then 2f from B to C, then there will be a deceleration. In that case, you have to consider the motion piece by piece, right? Such that within a piece, the acceleration is uniform, right? So if not, break the motion into pieces where A is uniform. Then use the equation from within that piece. Okay. Second one is, since V, U, A and S are vectors, except for time, the other quantities are vectors. So we have to take direction into account. So you know from physics, you know this, when we use equations, we specify a certain direction, right? So if the particle is moving from here, A to B, then we do the equations in this direction, right? So in that case, every vectors in this direction is taken to be positive, and every vector quantity is opposite to that direction is taken negative, right? For example, if your particle is taking motion from A to B, right? So U is here, then B, then acceleration is in this direction, right? Which means there will be a deceleration. Acceleration is in this direction, right? So if you do these equations in this direction specified, right? Suppose in this direction, then V is in this direction, so V is positive. U is also in this direction, U is also positive, right? Then acceleration A is in the other direction, so we have to take it as negative. But to make things simpler, we change the direction of A and put a negative sign. Right? We change the direction of A and put a negative sign. So in that case, all our vector quantities are in the specified direction. So this is how we can simplify problems before we solve it. Okay. So you don't have to write this down here. No need to write. The last one would be a very important thing. You don't have to use all four equations at once. Mostly you will have to use two equations. Two equations tops, right? Equations දෙකයි maximum යන්න අවශ්‍ය. तर ये equations දෙක ඔක්කොම equations දාලා මේව කරගන්න එපා. Equation දෙකයි අවශ්‍ය කරගන්න. For simple problems, you will be given three unknowns. You will have to find the other unknown, another unknown. In that case, choose the correct formula. Sometimes in advanced problems, you will be given two unknowns. Two unknowns විතරක් දෙනවා. එතකොට two unknowns විතරක් තියෙනවා නම් two unknowns, maximum there are four unknowns, right? Maximum there are four unknowns in a formula. Then how do you find the other two unknowns? Whenever you have two unknowns, you need two scenarios or two data. එතකොට තව data දෙකක් වැඩිපුර ගානෙම කියන. Right? So that's how you build up on it. So maximum you will have to do two equation steps, two formulas or equation steps, right? So please keep that in mind. Now, keeping this in mind, we'll move into simple questions now. So I would do one or two simple questions, then I will list out, V, U, and T, some quantities. Then you will be asked to find the other quantities. So that would give you a good practice, right? එතකොට අපිට දැක්ක ගමන් equation එක ටක් ගාලා උඩට යන්න මේ මට්ටමට එන විදිහට මම මේවා ටිකක් list out කරන්නම් problems කියන්නේ නැතිව. ඒතකොට ඒ ටික ඔයගොල්ලෝ කරලා ඉන්න.